Hey everyone, in this video I am going to cover primitive and non-primitive data types in depth. By the end of this video, you will know where the primitive and non-primitive data types stored, why non-primitive data types are different from the primitive data types, what is stack and what is heap. So on my screen, I have listed all the primitive and the non-primitive data types. First, we'll discuss about the primitive data types. Then we'll discuss about the non-primitive data type. We'll write a small code. With the help of the code, we'll understand the working of the primitive data types. Here, I will declare a variable const a is equal to 2. You can use the let as well. It's up to you. Now, if I click on run, nothing will happen. But internally, when JavaScript execute this line, it will store this variable into a memory location. And that memory location is called stack. So note it down, all the primitive data types are stored in stack memory location. Let's understand this with the visuals. So we'll open the canvas. I have already drawn a stack. So when JavaScript execute that line, it will create a variable into memory location and assign the value 2. Now let's write some more code. We'll declare a second variable b and assign a value of 4. And when JavaScript execute this line, it will create another variable in the stack memory location and name it b, and it will assign the value 4. After this, what we will do, we will just log this value with the comparison. A is equal to b or not. So I will do the strict check. So now we will understand how this line executes. When JavaScript reaches to this line, it will try to fetch the variable value from the stack. So in the stack, the variable value is 2. So I'll replicate this. And here it will replace the a with the 2. Similarly, when it goes to the stack, the value of b is 4. So it will replace b with 4. Now if I click on run, it will return false because 2 is not equal to 4. If I change the value 4 to 2 and click on run, then it will return the true for this. Let me comment this. In the memory location as well, it will change this value to 2. And this same behavior you will notice for all the primitive data types. And these are the primitive data types that you can try on. We will take one more primitive data type, that is string. So let's check with string. We'll create a string and assign a value my name. Similarly for b as well, I will assign my name. Now in the stack as well, we have to replace. So when JavaScript execute the first line, it will change the value to my name. Similarly here as well, it will change my value to name. We will delete the old value. So let's delete this. The second one is done. So leave it. Now when it execute this line, it will replace a with Aman and it will replace b with Aman. Sorry, I made it small. So let me make it capital. So this will be similar for all the primitive data types, and all the primitive data types are stored inside the stack. Now let's see about the non-primitive data types. So inside the non-primitive data types, we have the object, array, functions, these things. So we will check for the object. So I will replace the string with an empty object. Similarly, I will replace the b with a different object. So we'll take the same values. So now the question is, will JavaScript store the non-primitives in stack as well or in a different memory location? Let's see inside the visual. You can see we have a different box as well. And in this box, JavaScript store all the non-primitive data types. So this is a memory location and the memory location name is heap. So all the non-primitive data types are stored inside the heap. So when JavaScript execute this line, it will store this value in heap. So we'll first create a memory location with the name as A035. Let's move it. Not this one, this one. And this memory location contains the value. So in our case, it is an empty object. Similarly, for the b as well, we will get a different memory location. So we can name it A036. And similarly, we can copy this because we have the same values and this will contain this. Now you will ask, like in the stack, we have assigned the variables a and b here. Why we are assigning a memory location? So the reason is JavaScript stores all the non-primitives in the heap, but so while executing, it will takes the value from the stack. So just give me 2 minutes, it will get cleared. So we'll remove these values. We don't need it. Now let's do the same exercise again. When JavaScript execute this line, it will store the value in the heap. Now this memory location gets stored inside our variable a. So we have to write A035. Similarly, when JavaScript execute this line, it will store the value in the heap into some memory location, and this memory location is stored into a variable b, and we have to write A036 here. This is called the reference. So in JavaScript, for non-primitives, variable holds the reference of the value. It directly doesn't hold the value. So if you run this as well, it will give us false. And the reason is, when JavaScript execute this line, it will go to the stack and see what is the value of a, and the value of a is A035. So it will replace it to A035. Similarly for b, it will replace it to A036 because that is our memory location for b. And these two numbers are not same. That's why it will return false. So the question is, why JavaScript stored these primitives on the stack and the non-primitives on the heap? So in stack, JavaScript only stores the small values. So if we see the string, numbers, so these are the fixed and small values. But when we talk about the non-primitives like array, functions, objects, these can contain multiple values. Okay, so for example, this object can be large. So here it can contain multiple properties. So for example, we will define a property message and assign us empty string. Similarly, we can define other properties and the other functions. So these are the dynamic values, and that's why JavaScript store all these values inside the heap, and the heap reference will be stored inside the stack. Now let's check with an array. So I will remove this object and create an array and fill some values. Similarly for b as well, I will fill the values 1, 2, 3. And when we run this program, it will still return the false because it will again compare the references rather than values. So that's why when you compare non-primitive data types with the triple equal to operator, it will always give us false. And sometimes the non-primitives are very tricky. Okay, so let's understand one example. I will clear this complete code. We'll declare a variable b and assign a value 2. Now in the next line, I will reassign this variable to a different value to 4. Now in the second line, we will create an object and we'll name it c. And in this object, we will define a property text, and this text contain like this video. Okay, and what I will do now, I will just try to change this text value to a different value, that is thanks. Let me print the value of b and c. So it should be console.log, and here I will print the b. Similarly, I'll copy this and print the value of c. Just pause this video and try to guess the output of b and c. I hope you have guessed the output. Now when we click on run, first we will get the error assignment to constant variable. So JavaScript don't allow constant variable reassignment. But what if I just comment this code and run it again? So you can see we didn't get any error, but it updated the object. But why? Before answering this, let's do one more exercise. And now I will just try to reassign this c to a different object, and this can be an empty object. And if I click on run, you can see we are getting the same error. So in JavaScript, for non-primitives, the variable values are the references. So you can't reassign the references, but whatever the value stored inside that reference, you can modify that. These are the basics of the data types. People get mostly confused in these kind of things. Okay, so this is for the reassignment. Let's do one more exercise and I'll clear the complete code, not the complete one. Let me remove this commented code and this one. We don't need this as well. Okay, now what I want to copy this object into a different variable. So if I write const d is equal to c, and for the d I want a different text value now, and I will change two things. Let's print both the variables. So console.log, and we will print the C and the D. Before I click on run, just pause this video and try to think what can be the output. Let's run it. You can see both the values has been changed. Do you know the reason? It's pretty simple. Now just tell me what this C contains. Does it contain this value, or it contains the reference of this object? It contains the reference of the object. So instead of C, it will assign the reference of object. So let's take the reference of the object is A035, and the C also contains the A035. Now what is happening? D and C pointing to the same object. Let's try to understand this with the help of visuals. So here we have the C and D, and we have this object. So in our case, what is happening? So this points to this memory location. Now when we are doing D is equal to C, so in this case we are assigning the memory location to D as well. So this C and D contains the A035, and this one as well, A035. So this will again point to the same memory location. So that's why when we change the value of the text, it got changed in both of the variables. So I have covered all the cases of the primitives and the non-primitives. Now there's one more question left, that if I have to copy the value of C into the D, how can you do that? So for this, you have to wait for the next video where we will cover in depth so how we can clone the non-primitive data types. The reason is why I'm not covering in this video, because we have to cover two more concepts and this video will be lengthy. If you have reached till here, please smash the like button and the subscribe button. This is Aman signing off. Thank you.